Not a lot of time today, and definitely a lot of stuff to cover. I did manage to share these so that you can download them, go them through later. There's quite a bit of content. So I'm hopefully going to get through three big questions for you today. What is AI? What's AI risk? And as a financial institution, what does AI risk management actually look like? So just a bit for context, so about me, my background is mostly as a scientist and entrepreneur. I have a very multidisciplinary background, which is to say I am not a traditional finance person. So I'm actually quite close to this technology. And in my previous life, I've had a chance to watch this thing grow. And so as part of that, I have a bit of a unique insight that I try to bring towards my activities to help define what it is we're doing. So to start off, we have to actually answer the question, what is AI? Now, I'm a particularly big fan of the Turing approach for how you actually define AI, which is if you think something is intelligent, or if you believe it is, then it is. And that may seem like a very simple kind of philosophical statement to make, but it's actually quite profound, and I like to do a little activity to help illustrate that for you. So let's start off with this. You will have 15 seconds, and now I'd like for you to tell me, is this real? Did I take a photo? Is A real, B real, neither, both? Any takers would like to expose their opinion? A is real. I'm hearing some A is real, B is real. Some of you are maybe a little skeptical. You'll say neither, both. Well, turns out B is real, so I'll tell you that much. And if you felt confident because you got that answer correct, could you do it 2.8 million times in a row? And I think the answer to that is no. And this is one example of an AI that has become sophisticated enough to actually generate something that could reasonably deceive you. And I've done this many times, and every time there is a split between who is real and who is not. So this is a very special thing about this technology for what it's actually done. It's now actually questioned your ability to tell if what you're seeing is real or not. But it's not just based on images, right? Anyone can draw a picture, that's pretty good. What about writing? That's a pretty human thing. Here are two little excerpts. See if you can tell which one I composed for the purposes of this presentation, or if one of these maybe was composed by a machine somewhere. And be honest with yourselves. But I can already tell from seeing some of these faces that you are questioning exactly which way this is going to go. So, any takers for A? Some takers for A, some takers for B? All right. Well, in both of these cases, the author was a machine. Not just any machine, this is one of the most sophisticated ones. This is GPT-3, and they actually wrote an article for The Guardian. And this is about a little bit over 2 years old now. So this is actually quite a bit old technology, and it's actually gotten even better since then. And this is really one of the things that we want to talk about when we talk about AI risk, is that it is not about the technology, about the techniques and the machines that you've built into it, but about that very fundamental piece that we just covered right now, that you cannot discern the machine output from a human output, and that is a concern. So when we talk about artificial intelligence, some of the issues that we bring up are things like demonstrating natural intelligence. We assume we are intelligent, and therefore we try to somehow mimic that. But there is an issue with that because the language we use to describe our intelligence, like cognitive intelligence, includes things like perception, attention, memory, reasoning. But for AI, we have different terms. We've got image recognition, natural language processing, recommendation systems, speech to text. But it's important to note that even with this sophistication, today CAPTCHAs still work. So if you look at that image and one of these seems like a muffin, not a chihuahua for you, a very human thing to make mistakes, but a machine cannot do this very well. And so just to bring the point home, when we talk about AI and AI risk, I'm not really starting to speak specifically about a type of technique because there are many different ways to achieve this result. And in the history of AI, we've seen the techniques become more sophisticated with expert systems, Eliza, the first chatbot, on and on until AlexNet, et cetera, bringing us today where we have things like DALL-E that are incredibly powerful. Now, a very unique part about AI that we have to discuss is machine learning, which is really where we've seen a lot of the advancements come to play. And I know there's lots of experts in here, so just to make sure we're on the same page, there's basically 3 types of methods, sometimes a 4th if you consider semi-supervised. But essentially in supervised, you know what the outcome is, and you know what the data set is, and you can teach it to be correct. In unsupervised, you are allowing it to figure out what's the commonality, essentially grouping. Sometimes we call that the k-nearest, et cetera. We have other terms for it. And then we've got the reinforcement, in which it's not necessarily learning from the previous one. It's actually interacting with the environment, trying to figure out the next best move. So it's learning moving forward instead of learning historically. The important part to note here is that this is all trying to mimic what we do as humans. The idea is we have an experience. From that experience, we determine what would have done to make it better. Maybe we do it better the next time. And then when it comes to machine learning, there's also a big difference when we talk about, let's say, deep learning or classic machine learning. So in classic machine learning, we've got things like we define some features for the face, maybe the roundness of the face, distance between eyes. If a person's distance between the eyes is greater than 10 inches, it can't be a human, right? And then we run classifier algorithms, right? These are very well-known mathematical methods that helps fine-tune our approach so that we can come up with that classification. Whereas in a neural network, we give that up. We say, you know what, you figure it out. Allow the machine to run it and make that decision. The question is, why are we even using this? And when you look at the graph on the bottom, you can see why we've gone that route. Is that when we talk about that threshold of human performance, while leveraging deep learning, we actually started to supersede what humans can do in many scenarios, which makes the technology essentially comparable and so very useful for us. And that's why we see the explosion that we see today. But just to help illustrate just how this is perhaps not as intelligent as we think it is, when we have this AI black box in here, I've blacked out the whole thing, let's see if we could go walk through an example of what would a machine learning or deep learning in action look like for, say, classifying, is this a dog? Well, first you've got to stay with the picture of whatever it is that you have. And then I'm going to lift the black box now so we can also look inside the machine. And so stepwise, we start with something called labeling. I decided that this is a dog. I've labeled it this is a dog. Because it's a computer, it's going to have to be digitized. I can't just throw an analog photo into this. That'll have some kind of data. And there's usually here, I call it scaled data, but it's just a processing, something that needs to be done to make sure that the neural network can actually consume this. And then we've got a lot of really great math, a lot of addition and multiplication, what we call these weights. Lots of experts in the room, so I'll just go through it. It runs through these layers, comes up with some numbers, and eventually comes to these outputs at the end. And then we can apply our perceptron idea. So we're going to say, well, if this node is more than 1, I'm going to call that a positive identification. And if it's not, it's not. And in this case, the bottom one says that this picture is a cat. So we go, okay, you're wrong. Now learn. Well, what is learning really? What we're just talking about is changing these weights, and there's lots of ways to do it. And it's a game of choice. There's lots of ways for you to get to this answer. But you'll run your way through it in a very efficient, sophisticated way, and then you'll come to your conclusion where, oh, now this machine has said that this is a dog. Training completed. But to most people, we only see the stuff that's on the outside. And as with most things, once you actually see how it's working, it doesn't appear to be so intelligent. You can see that there's lots that's going on with that. So what's this AI risk then that we need to be worried about? Well, one of the things that I brought up earlier was your ability to be able to discern what is a machine when interacting with it, and also the sophistication that it can bring to the table. But there's a bit more to it. Whenever we look at the AI risk landscape, it's important to note that we're going to be seeing lots of different vectors or different spaces where these things manifest themselves, because it's a very ubiquitous technology. One of the big advantages of AI is that it's essentially a universal function approximator. You can use it anywhere. If you've got some data, you can try to use this. And so that means that we've got people that can try to abuse it. We've got concerns in terms of how legally you're able to do this, because now you can do this in places where maybe people aren't aware of the considerations they have to take. We can use this in terms of our defensive and offensive capabilities, even as an organization, not necessarily as from an abuse perspective. And we're also dealing with a fairly sophisticated, complicated machine, so failures and malfunctions still exist here, but there's some new ones that are associated with it. as well as sort of the unintentional new ones that we have. We got things like biases that are being introduced that we never really had to care about, lack of training because of the novelty of it. It's not until very recently that you could potentially get a degree. There's no professional association of AI practitioners. So this is all the kind of stuff that kind of goes into some of these risks. And the reason why we are having these conversations today is that when we look at the history of AI, a lot of things have happened that have essentially put a bit of a black eye on it. It was supposed to be an incredible technology. It's meant to essentially mimic what we can do. But guess what? Humans also do bad things. And so not surprisingly, we saw things like in June of 2015, image recognition algorithms deeming something to be racist due to misclassification. This was from Google. 2016, Microsoft's chatbot Tay did some horrible things as well. Amazon also got in hot water, as we've already kind of covered today. And the hits just keep on coming. Now we see the financial industry being swept up with Apple over the gender bias allegations. In this case, is the Apple Card Goldman Sachs partnership. But also not restricted to there. No, here in Canada, we had Cadillac Fairview, where we saw privacy laws being broken. Essentially, facial recognition, which was a great technology, let's use this, actually was breaking a lot of people's rights. And even government can get in hot water. In the case we had Australia government actually just about settling about a $1.2 billion lawsuit over its robo-debt scandal, essentially trying to automate the issuing of debts, and ended up issuing, because of the scale that it operates, a very large number of wrongly issued debt payments. But as I brought up earlier, I think when we start talking about some of these AI risks, I think one of the unique ones that's very popular but needs to be brought to attention, I think, from a financial institution perspective, is deep fakes. Now, for those who are unfamiliar, I don't think there's been any here, but the deep fake is essentially any kind of video, photo, or audio recording that appears to be authentic, but in fact is not. And this has actually been used to facilitate fraud already. So we see that in 2019, they used voice cloning technology to mimic a CEO's voice, essentially called an executive within the firm and said, hey, I'd like for you to authorize this transfer. And just imagine that your CEO has just called you, sounds exactly like him, has their cadence, and now talks about what exactly happened here and says, hey, I'd like for you to make this transfer. How many of you will be willing to tell your CEO, no, sorry, I don't think that this is you, hang up the phone? Well, it happened again, this next time in Dubai, but now instead of a few $100,000, we were talking about millions. So it's part of a very elaborate heist that used fake documents, also auto-generated, and cloning voice technology that played a pivotal role in giving the confidence for the individual to authorize the transaction. And this is an important thing that we need to start paying attention to, is that trust is a big part of the currency within financial institutions. Wherever you are, you need to have some kind of certainty, and it's a people business. You need to be interacting with people. And so for us, the idea of picking up the phone to confirm that this is who I am talking to seems very prudent. But this technology can actually exploit that. And all of the people questioned in these scenarios all come back with the same kind of commentary. I really thought I was talking to this person. But the issue gets a little bit worse, because deep fakes is not just the stuff of science fiction or a great technical team. It can actually be done just about anywhere, and this is here done with consent from one of my colleagues, Alex, and we wanted to test to see how well we could do this. And within about 30 seconds, we created this.
This is a deep fake test. This is a deep fake test.
Now, we created this on the phone using our LinkedIn photos for free. So where does this lead into problems for us? Well, we're already starting to see this manifest. In the US, we've already seen deep fake used as a notion for denying one of the provisions within the Consumer Protection Act case, essentially a robocall. If you call someone, if you receive a call, and you can just say, this was a robocall. Robocalls are illegal, you're not allowed to do this. But because a person can't reasonably discern if it was a person or a robot, they can always just say, yes, you were using robocalls against me. Hang up the phone. And that's a legitimate defense. We are also seeing this kind of synthetic identity fraud. So I take some stuff that is real, mix it up with a whole bunch of maybe those photos, I create a Facebook profile, some social media presence, maybe some blog posts, all synthetically generated, that augment the idea that I am real. And this is actually becoming one of the fastest growing types of fraud. And the FBI has also taken notice of this, saying that this kind of business identity compromise, the idea of someone calling you saying, I'd like for you to perform this transaction, is actually very likely to happen, as we're already starting to see, and could actually pose a very significant impact. And so that is one type of AI risk that's very interesting to me to think about, how do we actually manage this? Now, the next one that has been coming up quite a lot is the idea of artificial intelligence and bias. Now, when we talk about bias, bias is not an AI-specific problem, but it is an interesting notion that a machine could be called to be exhibiting bias. Well, how could a machine be biased? Well, it turns out that we don't actually have a great answer for a lot of these. So when we look at artificial intelligence in the case of like facial recognition, we see that it's actually doing a lot more than trying to find out if there's a person in there. Very easily, these technologies, and this is an image from the World Economic Forum, already tries to call out gender, age group, ethnicity. Could these things actually be determined from an image? What's the error rate on this? How far has this gone? There seems to be a bit of a scope creep in that sense. But even further to that, when we actually try to audit the performance of these technologies, and facial recognition is a very popular example of this, we see that the performance varies quite a bit. And here I've got 3 examples of them, IBM's, Microsoft Face Plus, but you can see that there's a very large difference between them. And basically, no matter what you do, this kind of thing shows up. It's not just a data problem, it's not a machine problem. This is also true for the text. That same engine that wrote that article also has biases towards gender. And then the other vector we have to consider now is that we've got AI versus AI. So the ability for an AI to figure out all the flaws that you couldn't possibly test for. And there's lots of different approaches for this. Some of them include things like data poisoning, where I can change an image so to the point that you can't, again, perceive that it's been modified, but can actually significantly affect the AI's performance. One pixel attack, which is something that we think is obvious, but to an AI could actually significantly alter the image. Or even new model backdoors, things like master face, the equivalent of a master key for a facial recognition program. So in this last little piece, I'm going to talk a little bit about some of the things that you can do or that financial institutions can look at when considering how to manage some of these AI risks. And this is by no means a finalized matter, and there's lots of work that's happening here. But essentially, you can start imagining that because of its widespread, there's going to be an application of AI risks to a variety of your different operations. So you could be facing credit risks, market, if you're doing insurance as well, strategic risks, because companies that do adopt this technology tend to get a better return than the competitors who don't, as well as regulatory compliance, because the technology is moving faster than the laws. We do have some regulations popping up, but we actually haven't seen them materialize yet. So how do you actually prepare yourself for the laws that are not yet written? As well as the operational risks for, how do you have this technology? Perhaps you have the right principles in place, but the ratios are going to be a bit off. Now, I've already covered some of this, so I'll kind of move through, but in the EU, the basic idea is that they've tried to categorize this into things that you can't do, things that are very dangerous to do with a high risk, that you should get some certification, and then sort of limited and minimal risks, things like AIs in video game. Maybe you don't need to disclose that. What's the real risk here? And Canada has a similar approach as well, too, with ADA, except that they've only gone as far as to define high impact systems for the harm that it creates. So they haven't been quite as granular, but across both of them, we're talking big fines, definitely don't harm people, don't discriminate. If you're using AI for this, that's going to be very bad news. And in the US, it's actually where we've seen a bit more of a laid-back approach. They are waiting to see, essentially, what plays out, but they have already stated that I don't care if you're using an AI, if it breaks something, an existing regulation like the Fair Lending Act, you're in trouble. You can't say the AI made me do it. Now, as an example of how do we control some of these risks, now, if I look at this process for how an AI is developed, this is probably fairly common. You come up with some idea, you try to ingest it, and maybe you play with your data a little bit, train it, and then launch your product. And for those with a bit of a risk background, you can already see that, okay, there's a few things missing here. Well, where's your verification? Who validated this? Where's your sign-off? Who's doing the maintenance for this system? How has it been thought out? And so here I've got an example of, let's say you come up with an AI system and you're trying to have a fintech and you're trying to have lots of approvals. So in this case, let's say you deployed your AI and then a year later you find out that it's doing predatory lending. Well, let's take a look back and look at how some of these things should have been looked at. So in terms of human bias in your initial business goals, did you include an appropriate understanding? Because the AI doesn't have context. When I said train this AI, I also meant train it lawfully. Make sure it knows all the regulations, but if you don't feed it that, it won't know it. For the data ingestion, did you even have the measures or the means to be able to measure bias? Maybe your data was anonymized. You wouldn't know who you were targeting. For your data processing, did you have the right standards in place, data management practices, and so on? And for your system training, how robust and how thorough was your thinking for how to make this system actually work? Now, it seems pretty easy to kind of point that out, but in terms of actually implementing this, there's a few key risks for AI risk management. The first is that risk measurements are notoriously difficult here because they can have both a temporal dimension and also how you measure some of these things like fairness and harm. Who defines this? It's, again, not an AI problem, and any kind of definition you have is going to be jurisdictionally varied, so that creates a problem, especially for like global organizations. A risk threshold is also tricky territory. How much bias are you allowed to tolerate? And so when we talk about how you could actually do this, I'd like to walk you through a bit of an example for how this solution could be done properly. So throughout your ingestion, make sure that you're working with your data to structure it properly, build up your data sets, and have a bit of a structure for how you're both training, testing, validating, and evaluating. Make sure you decide which method is most appropriate for you, whether it be classic machine learning or maybe a deep learning approach. And then go through your training processes. Make sure to have some kind of verification system in place that can independently verify what it is you're trying to do. And if it doesn't work, go back. And if necessary, perhaps even go back to your original steps and requirements to make sure you chose the right approach. But if you have, then make sure that there is a business understanding for what you're about to do. And if you don't have it, stop. And if you do, launch it, but make sure that the road doesn't end there, that it keeps going and you can have proper oversight for how this works, and that you go back whenever needed. Now, it's already been brought up here today, but it's important to know that within this picture, it's not very easy to see that about 60% of the time in these projects is actually spent on the data. So make sure that you have a good process for your data for how you manage it, because this seems to be the most costly place. Make sure that your stakeholders include not just the people developing, but all the way to the external, so your operators, evaluators, and the general public. Make sure that your solution isn't built in a vacuum. And when it comes to fairness, think of it this way. When you take your use case, ask yourself, am I trying to be intentionally biased? If you are, stop. If you are not, then try to see if you can measure any kind of historical biases, what awareness you have to it. You may be able to measure it, you may not. If you can, and it is biased, stop. But if not, make sure that you have processes in place to help mitigate the harm and detect it early on, so you don't wait a year, 2 years, or 400,000 wrongly issued ads later to catch the problem. And when it comes to transparency, make sure you understand the difference between interpretability and explainability. AI is not necessarily the right choice to make all the time. So make sure that you have a solution that fits your purpose and understand the trade-offs that you're doing. If your performance is the key driver for it, interpretability, no one cares, explainability, maybe that is an appropriate solution. But make sure that you're picking something that fits with your needs. And so just a few takeaways, and I know that there's been quite a bit of content popping up in there, but in terms of an important strategy for managing AI risk, the 4 principles I like to bring up are to make sure that you have build awareness, like what we're doing today about AI risk, encourage diversity within your teams. That's been shown to be a good way to help mitigate some of these concerns. Focus on the outputs, not how you did it, but what you're actually causing once you've done this. And make sure that you have good communication techniques, because AI is now crossing everybody. You can't just have technical people building it up. You have to be able to communicate it, kind of like we saw earlier on in terms of how you can explain it. And so remember that AI is already impacting many parts of our lives, but it also brings immense opportunities. And that AI can convincingly, as we proved today, deceive, coerce, manipulate, discriminate people. So we cannot be naive about this, and we must manage the risks. And that managing this risk means considering both the opportunities and the risks that it brings to make sure that the technology could actually be something trustworthy that is used for the greater good. That's all that I got for today. I'll open up some questions if there are any. Otherwise, thank you so much.